In this video, we will get a primer on how to think about real-time data from the perspective of a data scientist. So, if you have been sort of classically trained as a data scientist, you probably have seen some version of this pipeline before. This is sort of the iconic image of the data science pipeline that starts with ingestion and goes through wrangling and analysis and application and visualization and then starts over. And in practice, we're taught to know that, it is a cyclic process. It's not linear. But I think one of the key things that is missing from this is kind of the chicken and the egg problem, right? So a lot of people feel like they can't get started because they don't have enough data yet. Another problem is that if you make it all the way through, and let's say you do have enough data, you make it all the way through this pipeline, usually there is this sort of need to redo some of the work in order to get the model deployed. So the MLOps problem is probably one that you've heard about. Another thing that you may have heard about is model drift. So, once, let's say we make it all the way through, we get it deployed, but then we start to notice that the model is not performing as well as we expected it to when we were training it. Or maybe the data is getting old, right? The data that we have doesn't really represent, reality right now. There's also this problem of being able to audit and introspect into kind of historic training data sets so that we can understand why a certain model might be behaving in a strange way. And kind of there's this possibility that you might spend quite a lot of time training a machine learning model just to realize that that's actually not the solution that's called for. So because of all of these things, I would like you to consider maybe taking a slightly different perspective on data from the perspective of doing data science so that you can set yourself up for success when you get to industry. So in order to understand that, I want you to know the difference between batches and streams. So where does a batch come from? Well, the first thing is that when you hear the word batch, I want you to be thinking about a snapshot in time. So, these are dumps sometimes from a database table that you've been able to acquire from maybe the DBA at your organization or somebody else who has access. So they get like a large dump that's maybe many rows, and columns from a table, or maybe the product of a join from a few database tables. You can also get this from materialized views. So, maybe you're not actually dumping out the data, but you're sort of snapshotting a bunch of tables and their join in memory all at once. Potentially, this batches of data are coming from queries against data APIs that are either RESTful or GraphQL or maybe SOAP. There's, third-party data assets that you can acquire. A lot of them are for purchase, like Dun & Bradstreet data. There's the UCI machine learning repository, which is the source that many students start with in order to get batches for training. Academic papers, which is where most of the Berkeley data sets come from also, and then other found data sets, right? So this is kind of all the stuff that you find on the internet. These are all batches. So what are the pros of working with batches of data? When you're a data scientist? Well, I think the main one is that it sort of coincides with many different academic disciplines' mental model of what data is supposed to look like, right? So if you sort of think about the roots of data science and think about where these ideas came from, areas like economics and epidemiology have had a huge influence on data science because a lot of the models that we use in industry, originally come from ideas that come from these fields. These are all fields that sort of assume that you will have some historic batch of data and that the goal is to understand the past. But that's a very different thing than trying to predict the future. But with batch data science, one of the real conveniences is that, you can kind of leverage this shared mental model across a lot of different disciplines. Related to that, a lot of the linear algebra based models, and really, many, if not most machine learning models that you're going to be exploring, I'm sure are, have some basis in linear algebra. Many of those do sort of are set up to expect large batches of data that are all held at once in memory in order to compute things. The open source tools that you're probably learning, PyTorch, TensorFlow, scikit-learn, Yellowbrick, are all sort of architected, assuming that you will be handed a batch of data, many rows, all at once. And batch data science is better for certain kinds of use cases like recommender systems and building graphs. But probably you sort of knew this was coming. There are some downsides. One is that it's very hard to model sequence-based data using batches because you don't necessarily get kind of an organic flow of what's changing. You also have to wait for enough data to accumulate. So this is one of the things that we said in the earlier slide. A lot of people feel like they can't even get started on machine learning because they don't feel like they have enough data. And that is one of the problems with sort of the batch mentality. It's hard to map our data back to the database. So if we're kind of getting snapshots from a database, the database is changing under the hood. So every time something new gets written to the database, our old data set that we snapshotted is no longer real. So it's actually quite hard to go back and remodel sort of what the data looked like, at a certain time of training if you are using exports from a live database. And, as I've already mentioned, with batches, MLOps is quite challenging. And you might suffer from either model or concept drift. So this is where streams come in. So streams are basically what actual live data is, right? So it's a bunch of things that are just constantly changing. And so you can sometimes access these directly from a database. So some databases do expose change data capture logs, although that's not common yet. You can also get data from real-time data APIs. We will be discussing this in an upcoming video. You can get them from live running applications, from streaming devices, from hardware devices like IoT devices. You can get them from customer interactions and behavior and social media interactions and feeds. You can get these from logs, kind of just automated logs that are getting collected in the back end. So there are some real pros to kind of thinking about data science in this streaming asynchronous fashion. One is that instead of putting all of your chips in the machine learning basket, you can also do some lightweight types of data science. And so, an example of this would be taking a running average, right? This is something that is quite easy to do on a stream of data. It doesn't require you to, kind of have a huge batch of data. And sometimes all you really need is a running average in order to understand how a value is changing over time. Asynchronous data science is also good for data when you want to model sequential data. And it's much more performant because instead of having to hold a huge batch of data in memory all at once, you can leverage algorithms that are able to process one piece of data at a time, or very small bits of data at a time. And the other nice thing is that once you've kind of set up a asynchronous data pipeline, you can set it up so that the model is sort of just always refreshing and getting retrained. And so you don't have to put as much work into manually updating or monitoring the model to see if it's drifting. So it's a way to kind of hedge against concept and model drift. There are some cons. Asynchronous data science might not be suited to the problem that you're working on. So if you're doing collaborative filtering, potentially asynchronous is not the way to go here. And along those lines, some algorithms don't parallelize very well, and they're hard to create in online models. And a lot of the tools out there that you will have heard of that are sort of associated with asynchronous programming maybe don't feel as welcoming to us as data scientists. But I have a recommendation if you're looking for something. The Ensign package, the Ensign tool, is a really nice way to kind of leverage some of these things from a sort of Pythonic data science perspective. And so we'll talk more about Ensign in a upcoming video. And then another thing is that, when you are doing asynchronous programming, asynchronous any kind of development, you do have to shift a little bit away from the object-oriented frame that we usually use in Python towards something that's a little bit more functional. So you can think about transformations that are happening as events flow through the system. Thanks so much for joining this video on real-time ingestion, and I hope that you'll join for an upcoming video where we dig more into how to get started with Ensign.